Hello all, I am Dr. Karthika from Department of Biomedical Engineering, SNS College of Technology, Coimbatore. And in this Jan 2025 lecture series, we are going to discuss about some topics in biomedical image processing. The first topic we are going to see here is relationship between pixels. In this, we are going to discuss about the basic relationship between pixels in image processing. Okay, shall we start? Okay, see here. Here we have definition for some basic relationship between pixels. Here consider a digital image because here we are using digital image. The image is represented in terms of f of x and y. Here the pixels are q and p and subset of pixels of f of x y is represented in terms of s. Do remember one thing, the image is represented in terms of pixels. That image here we represent as f of x and y, f of x comma y. X and y are the coordinates of that particular image, and that pixel is q and p. Subset of pixel is s. See here, conventional indexing method. See, the pixels are arranged in terms of x and y coordinates. X minus 1, y minus 1, x, y minus 1, x plus 1, y minus 1 in row, and in column wise we have x minus 1, y, x, y, x plus 1, y, and in the third row x minus 1, y plus 1, x comma y plus 1, x plus 1 comma y plus 1, like that we are arranging pixels of image by using this conventional indexing method. See, the neighbors of a pixel, we have two coordinates. The first one is Cartesian coordinate x and y, and also we have image coordinates. See, the neighbors of pixel, how it is represented in terms of rows and columns. See, your image is f of x and x comma y. Here it is represented in terms of rows and columns. F of 1 comma 1, f of 1 comma 2, f of 1 comma 3, f of 1 comma 4, like that it goes on in row wise, same as repeated for column. Here the numbers and coordinates, it represents the pixel of that particular image. See the coordinates x and y. See here, the neighbors of a pixel is represented f of xy, it is equal to f of 1 comma 1, f of 1 comma 2, like that we are having. And a pixel p at coordinates xy has 4 horizontal and 4 vertical neighbors. Their coordinates are given by x plus 1 y, x minus 1 y, x y plus 1 and x y minus 1. Here we have f of 3 2, f of 1 2, f of 2 3, f of 2 1 in the above set example. This set of pixel is called the 4 neighbors of P, denoted by n4 of P. Each pixel is unit distance from xy. See, second, a pixel P at coordinates xy has 4 diagonal neighbors. Their coordinates are given by x plus 1, y plus 1, x plus 1, y minus 1, x plus 1, y plus 1. Sorry, the third one is x minus 1, y plus 1 and x minus 1, y minus 1. Here we have the image coordinates f of 3 comma 3, f of 3 comma 1, f of 1 comma 3, f of 1 comma 1. This set of pixel is called the diagonal neighbors of P, denoted by nd of P. Diagonal neighbors and the 4 neighbors, it is equivalent to 8 neighbors of P. They are denoted by n8 of P. See here, n8 of P is equal to n4 of P plus nd of P. Okay. See, a pixel P at x comma y has 2 horizontal and 2 vertical neighbors, x plus 1 y, x minus 1 y, x y plus 1, x y minus 1. This set of pixel is called the 4 neighbors of P, n4 of P. It is represented by n4 of P. See, the 4 diagonal neighbors of P are nd of P, x plus 1, y plus 1, x plus 1, y minus 1, x minus 1, y plus 1, x minus 1 and y minus 1. n4 of p and nd of p, it gives n8 of p, the 8 neighbors of p. See, neighbors of a pixel, here the neighborhood relation is used to tell the adjacent pixels. It is useful for analyzing the regions in image processing algorithms. Here, see here, n4 of p, which is equal to x minus 1y, x plus 1y, x y minus 1, x y plus 1. This 4 neighborhood relation considers only vertical and horizontal neighbors. Here, q n4 of p implies p n4 of q. See here, the 8 neighbors of p are nh of p, it is equal to x minus 1, y minus 1, x, y minus 1, x plus 1, y minus 1, x minus 1, y, x plus 1, y, x minus 1, y plus 1, x, y plus 1, x plus 1, y plus 1. The 8 neighborhood relation considers all neighbor pixels. See, diagonal neighbors of P, N, D of P. Here it is x minus 1, y minus 1, x plus 1, y minus 1. See here, x minus 1, y plus 1, x plus 1 and y plus 1. Here the diagonal neighborhood relation considers only diagonal neighborhood pixels. See, next one is, it is about connectivity. What do you mean by this connectivity? Why do we need connectivity in biomedical image processing? What is this connectivity? Actually, connectivity is adapted from neighborhood relation. Here two pixels are connected if they are in the same class, the same color or same region of intensity, and they are neighbors of one another, which is very much helpful for analyzing images in biomedical applications, for cancer reduction, diagnosing diseases like that we have. For P and Q from the same class, 4 connectivities. P and Q are 4 connected if Q and 4 of P. 8 connectivity if P and Q are 8 connected if Q and 8 of P. Mixed connectivity M connectivity. P and Q are M connected if Q and 4 of P. R, Q, ND of P and N4 of P intersection with N4 of Q, which should not be null. Okay, a connectivity between the pixel is very important one because it is used in establishing boundaries of objects and components of regions in an image. Here, the two pixels are connected if they are neighbors. The adjacent in some sense, n4 of p, n8 of p, their gray levels satisfy a specified criterion of similarity, equality. V is the set of gray level values used to define adjacency for adjacency of pixel value 1. Okay, we'll discuss about adjacency in next class. Thank you.